Okay, so let's take a look at a problem. We have two masses hanging over a pulley, and this is known as an Atwood's machine. And what we want to do is we want to know what's the acceleration of this thing going to be once we let mass 1 go. So we're like holding it in place, and then we're going to let mass 1 go, and the system's going to accelerate. Well, if we want acceleration, we're going to use Newton's second law, sum of the forces equals ma, and we're going to look at mass 1 for this. So we need to find out what forces there are. So how do we know what forces are on an object? Well, we draw the free body diagram, and mass 1 has tension pulling it up and gravity pulling it down. That gravitational force is down, tension is up. Which force is winning for mass 1? Well, the gravitational force is winning because it's going to accelerate downward. So when we do that, we need to bring this over, and we do gravitational force minus tension equals ma. We can divide both sides by the mass, and we get A as gravitational force minus tension over m1. So we get A equals little m little g minus tension over m1. And let's say that the mass of this is 6 kilograms, so we can put that in there. And what's the acceleration due to gravity on Earth? Yeah, it's about 10, 9.8. 10 makes the math a little bit easier, so we substitute that in, and we find that acceleration is 60 minus t over 6. But what's the problem with this as a result for our acceleration? Yeah, we don't know what tension is, so we have to go to m2 to figure that out. Because we have the gravitational force down on m2, we have the tension force up on m2, and what force is winning for m2? Yeah, tension's winning, so what we're going to do is we're going to have positive upward for this, which means we need to bring that tension over, and we have tension on 2 minus the gravitational force. Gravity's hurting it because that m2 is moving up, equals m2a2. Now remember that these are connected by the same rope. So what we're going to do is we're going to say that maybe this string is massless or very light and the pulley's massless. If that's the case, then these tensions on 1 and the tension on 2 will be equal, and we'll just start calling them T. So we get T equals, and we bring the gravitational force to the other side, mass 2 times the acceleration of 2 plus the gravitational force on 2. T equals m2a2. Remember, the gravitational force is equal to little m little g. And let's say the mass of this is 4 kilograms. Remember, they're tied together. So they're going to move at the same rate. So they're going to have the same acceleration. So from now on, we're just going to call acceleration A. So we get 4A plus 4 times, and remember the acceleration due to gravity on Earth is 9.8. We're going to call it 10 just to make math a little bit easier. And we get 4A plus 40. Now at this point, we need to combine these two equations. And we get A equals 60 minus the 4 plus 40 over 6. Remember to put quantity around that. So we get 60 minus 4a, and then is it plus 40 or minus 40? Remember, it's minus 40. We have to distribute that minus sign. We divide or multiply both sides by 6 to get that 6 out of the denominator, and we get 6a equals 60 minus 4a minus 40. Next, we need to add 4a to both sides, and that gives us 10a. And then on the right-hand side, we have a 60 minus 40, which is 20. We need to divide both sides by 10. And we get A, or the acceleration of this would be 2 meters per second squared. So a couple things to remember. Remember, we had two equations with two unknowns. Really, we knew what the gravitational force was. We could solve for that. We knew the mass. It was tension and acceleration. So we had to combine those two things using our Algebra 2 skills. And also just remember the motion of this. For the blue mass, it was accelerating downward, so gravity was winning, so we had gravity minus tension. For the green mass, it's accelerating upwards, so tension was winning, so we had tension minus the gravitational force.